All right, let's review everybody's favorite trig functions. Woo woo! Trigonometric functions. Again, this is prerequisite information to get into this class, right? You had to have had trig. So with your trig, you know these basics. We're just going to review your basics. People hear trig and a lot of times it gives them anxiety. Don't freak out about trig. We got this, right? I am going to go through some basics that we have here. When we're actually going through the lessons, we'll talk about the trig that goes with it, right? You have to have some basic working knowledge coming into this, but if you have questions, just ask. Just that easy. We've got this. So, trig, let's just start with the basics associated with trig. We're going to be looking at right triangle trig to begin with. If this is theta, right, my angle measurement, this is my y, this is my x, and then this is my r. So when I'm talking about right triangle trigonometry, right, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? SOHCAHTOA. Remembering that? So if I want to look at my sine of theta, here's theta, opposite and hypotenuse. That's going to give me y over r. Cosine is adjacent over hypotenuse. That is my x over r. Tangent is opposite over adjacent. And there's my y over x. Now, some things that I do expect you to know going into this is the reciprocal identities. So I know sine, the reciprocal of sine is cosecant. So if sine is y over r, cosecant is r over y. The reciprocal of cosine is what? Yep, secant. So then that's r over x. And then tangent is cotangent. Good. Good, right? So the reciprocal identities you've got. Also, some basics that we want to pull off here is I know if I'm looking at sine of theta, then those are the y values. That's the value of sine of theta, and you can see that here. Cosine of theta is going to be your x values, right? Okay. Now, in the course, I have a trig, quote unquote, cheat sheet. You can't see my air quotes because of just how this is recorded, but I'm doing air quotes. Cheat sheet. Those basic identities and formulas. Now, do I ever let you have any formulas on your tests or quizzes? That's right. Nope. So because you don't have any of that, you need to know these basics. If you want to refer to them so you can learn them, awesome. And that's why I put that in here. But I do expect you to know your reciprocal identities, your Pythagorean identities, your ratio, tangent, we already said was y over the x, so sine and cosine. Cotangent's reciprocal of that. These double angles and power reducing, these are going to make more of an impact for you in Calc 2. All right? So you're going to see this a whole lot more in Calc 2, and if you're at MACC, I know for sure we do this, but we will talk about this in Calc 2 when you need to use those. Pardon me. Then those will be brought up and make sure you get them. All right? Okay, but this is more Calc 2 kind of situation. I put the same thing in my Calc 2. But this little fella right here, dun dun dun, this is your best friend, right? So this is our best friend right here, this unit circle. Here's my expectation for the unit circle. I expect you to know what are called the quadrantal angles, which are along those axes. The fact that 0 degrees is this coordinate point. Pi is this coordinate point. Pi over 2 and 3 pi over 2. Typically, we're going to deal in terms of radians. So we'll have everything in terms of pi, so we'll be looking at our radians. Sometimes those angles come up, so they're on here too, but that's a thing. The other thing I expect you to know is quadrant 1. Because if you know quadrant 1, you know everything else. It's just reflections, right? Look at those positives and negatives. If I'm going this way, x is positive, right? This way, x is negative. Down here, y is negative. Up here, y is positive. You already know that, so you know which one's positive and negative. Now, I'll be the first to tell you, I am terrible at memorization. I legit am. And trig is tons and tons of memorization, right? But it also has tons and tons of patterns. If you know some basic trig, you can figure out the rest of it with those patterns. Here's how I do it. Lots of people have different ways that they pull this off. But here's how I do this. Oh, I just noticed this doesn't have a 2 pi on there. 0, 2 pi, same thing. Okay. Here's how I do this. You know some basics of fractions, and then you know this first quadrant. So I know that a sixth is less than a third, so pi over 6, pi over 4, pi over 3, pi over 2. If you know that, then all you have to do is count. Here's 1 pi over 3. There's 2 pi over 3. It hits us at the thirds. 3 pi's over 3 is just plain pi. Then you've got 4 pi's over 3, 5, and then 6 over 3 is 2 pi, right? You're just counting. So if you're looking at it, you just count it up. 1, 2 over 4 is 1/2, 3, 4 over 4, 5 over 4, 6 over 4, reduce, 7, and then 8, right? It's just counting. 1, 2 that I'm looking at here, 3 over 6, 4 over 6, then you've got 5. Now here's what I actually do when it comes to pi's over 6's, because everything, if you notice, this is a reduced fraction, reduced fraction, reduced fraction before you actually get to another pi over 6. 6 pi's over 6, back 1 is 5, down 1 is 7. Over 6, you've got 12, back 1 is 11. Right? Patterns. Basic fractions and patterns. All right? That's all that we're looking for. Now, some people do pi over 3 and pi over 6, figuring out which one is which, because they look the same, right? Again, however this works for you, go for it. Here's how I do it. I look at this 1/2, and this just about hits my x-axis right there at 1/2, so I know that for pi over 3, my x is 1/2, my y is square root of 3 over 2. For pi over 6, this is hitting my y-axis at 1/2, and that's how I keep those straight. However you do it is up to you. You don't have to do it that way, right? And we know that this is square root of 2 over 2. Sometimes this is written as 1 over the square root of 2. Those are the same. You just rationalize the denominator to get the square root of 2 over 2. But I want to make sure you know that those are the same, right? Otherwise, you've just got your basics. And then it's just a reflection. This pi over 3 and this pi over 3, still 1/2 square root of 3 over 2, 1/2 square root of 3 over 2. It's just negative over here on this side. That's it. All right? Okay, now let's use this a little bit. So I've got this page in your notes that you can see. It's also uploaded in the course. But I'm going to come back here because we still got plenty of room on this page right here, and let's do some examples. What if I wanted to see what is, here's example 1A. I want to find sine of 8 pi over 3. Now we have what are called reference angles, right? And coterminal angles. All of those things are happening. Obviously, 8 pi over 3 is going to be more than 2 pi. So do that. So whenever you figure out those coterminal angles, I'm going to subtract 6 pi over 3 because that's a full circle. That's my full 2 pi. This is now at 2 pi's over 3. So what I'm actually finding here is the sine of 2 pi over 3 because those are coterminal, right? Go to your unit circle. Oops, let me squeeze this back down here again. The sine of 2 pi over 3, because what you've actually done is you've taken this 6 pi, then you're coming all the way over here to this 2 pi to get this coterminal side. And the sine is which one again, the x or the y? The y. Good. So that's how I know that this is the square root of 3 over 2. Do you see what just happened there? So you take that unit circle, you use that unit circle, and then you can come up with those coterminal angles, and then that coterminal angle is going to help you determine where that is. Let's do another one. Example 1b. This is cosecant of negative 11 pi over 3. Ooh, but what happens when you have a negative angle measure? What does that mean? Yeah, good. So that negative angle measurement means instead of, going like the normal way like this, your negative angle measurement is going in the opposite direction. That's what your negative angle means. All right, and with that negative angle measurement, I've got this negative 11 pi over 3. Again, we want to figure out what is our coterminal angle. So I'm going to add 2 pi's to it until I get it to where I want it. So 6 pi's over 3 is going to put me at a negative 5 pi over 3. Now we can pull that around, or if I just want to make it a positive angle, I can add another 2 pi to it. And I just get a straight up pi over 3. So what I'm actually looking for is the cosecant of pi over 3. Right? So check us out. Cosecant of pi over 3. Now cosecant, what does cosecant go with? Sine again. Right? It's the reciprocal. So if I'm looking at this, if my sine is the square root of 3 over 2, I know I keep flipping back and forth, stick with me. So if I know the sine of pi over 3 is the square root of 3 over 2, and it's the reciprocal of this, that's where I get 2 over the square root of 3. And just leave it. All right? You have to know those reciprocals. That's coming into here. That's in previous information into the current lesson. So you need to know those reciprocals, and you need to know coterminal there. Right? Okay. What if just, because it's fun, I'm just going to write it over here somewhere. What if I want to do something like, I don't know, the tangent. Let me change my color so it can stand out. The tangent of something like, pi over 3. Just because apparently we're super digging on pi over 3, right? What if I want the tangent of pi over 3? Ooh, sine of theta are the y coordinates. Cosine of theta is the x coordinate. But I don't see a tangent in there, do you? Oh, good, 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 good. Tangent, we know, is sine over cosine, or we also learned that to be y over x. We talked about that already, right? Okay, so if I want the tangent of pi over 3, I'm looking here at pi over 3, and I'm doing the square root of 3 over 2 over 1/2, right? Then if you multiply by that reciprocal, you'll see those 2's cancel out, and I'm just straight up left with the square root of 3. All right, cool. What if I want the tangent, or even better yet, the cotangent, because let's spice it up a little, of 2 pi over 3? So the cotangent will be x's over y's, good, because it's cosine over sine. Negative 1/2 over the square root of 3. Watch that negative sign. Oops, 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 oops. Sorry. That's my bad. Square root of 3 over 2. And then my 2's again cancel, and I'm okay if you leave it unrationalized. Negative 1 over the square root of 3 suits me just fine. If you want to rationalize it, you can. I am not going to require that. All right?